So hi guys, this is another question from JEE Advance 2015, paper 1, maths. Okay, so this is a very difficult question. I'm trying to say it's a very difficult question, and you have to have proper knowledge of functions and integrals to solve this question. It's a very difficult, not, it's a difficult question. That's what I'm going with. So, they're saying that at f r to r be a function defined by fx is equal to box x, x less than 2, 0 x greater than 2, when box x is the greatest integer less than or equal to x. If I is this, then find the value of 4I minus 1. ठीक. So if I is given as minus 1 to 2 x f of, let's just leave it over here right now. So let's just make the fun, like we need f of x squared and f of x plus 1. Like why not define these functions first, right? So basically f of x squared is equal to uh, greatest integer of x square for if x square is less than equal to 2, and 0 if x square is greater than 2, right? Okay. And f of x plus 1, f of x plus 1, this is equal to greatest integer of x plus 1, uh, if x plus 1 is less than 2, and 0 if x plus 1 is greater than 2. So these are the two functions. Now let us define these functions in the interval of minus 1 to 2. Okay. So f of x square, if is equal to, I'm going to define in this interval. So greatest integer of x square when x square is less than 2. Okay, so if x square is less than equal to 2, then x will be between minus root 2 to root 2. Okay, so x belongs to minus under root 2 to under root 2, and if x belongs to minus infinity to minus root 2 union root 2 to infinity, this is 0. And similarly, in this case, f of x plus 1 is equal to, using the properties, I can say this is greatest integer of x plus 1 when x is less than 1, taking 1 in on this side, and 0 if x is greater than 1. Okay, so now f of x square, this is equal to, I'm going to break this function. Okay, I'm going to break this function into several parts. So the first part would be x belongs to minus root 2 minus 1, and then it would be x belong to minus 1 to 0, and then the next part would be x belong 0 to 1, and the next would be x belong to 1 to root 2, and the next would be x belonging to uh, root 2 to infinity. Okay, so I'm going to break this function in these many parts. And similarly for this also, I will be breaking this into parts such that when x belongs to from minus 1 to 2, right? We have to go from minus 1 to 2. So from minus 1 to 0 first, and then from 0 to 1, and then from 1 to 2, and then from x greater than 2. Okay. So from now see, if x belongs to minus root 2 to minus 1, then x square will belong to 1 to 2, right? So if x square belongs to 1 to 2, then the greatest integer would be 1, of course. So to write 1. Now if x belongs to minus 1 to 0, then x square belongs to 0 to 1. And if x square belongs to 0 to 1, then greatest integer of x square will be equal to 0. Again, same case, if x belongs to 0 to 1, x square will also belong to 0 to 1, and the greatest integer would be 0. Now, in this case, if x belongs to 1 to root 2, then x square will belong to 1 to 2, and the greatest integer would be 1. But in this case, uh, when x is greater than root 2, f of x square is defined as 0. So I'm just going to write 0 in this case. Okay. Now in this case, I can say that when x belongs to minus 1 to 0, the greatest integer would be minus 1. So f of x plus 1 would be minus 1 plus 1, which is 0. Now if x belongs to 0 to 1, the greatest integer would be 0. So it would be 0 plus 1, 0 plus 1, which is 1. Which is 1. And if x belongs to 1 to 2, now if x is greater than 1, then f of x plus 1 is equal to 0. So I'll just write 0 over here and 0 over here, because x is greater than 2 in this case. And if x is greater than 1, f of x plus 1 is equal to 0 according to the definition of this function. Okay. So now we have simplified the functions, and now just evaluate this. Now let's just evaluate this integral. So the integral which we have to evaluate is I is equal to integral of minus 1 to 2 x into f of x squared upon 2 plus f of x plus 1 dx. Now I'm going to break this integral in integer pieces to simplify this further. So it would be from minus 1 to 0, then it would be from 0 to 1, and then it would be from 1 to 1 to, let's see, from so we can see that f of x square is breaking at root 2. So I'm going to include root 2 in this case, because the f of x square is breaking at root 2. It's discontinuous in that case. So we will have to break the integral in order to create a proper definition of the function. Okay. So we have to break it because it's discontinuous at root 2. And afterwards, in the end, from root 2 to 2. Okay. So now if x is from minus 1 to 0, then f of x square minus 1 to 0. Minus 1 to 0, then f of x square is 0. So this whole thing will become 0, because the argument inside the integral is 0. And again, if x is from 0 to 1, again f of x square is 0. So again, this whole integral will become 0. And if x is greater than root 2, again f of x square is 0. So this whole integral will also become 0. Okay. Now, if x is from 1 to root 2, f of x square is 1. So it is x into 1, which is x dx, upon 2 plus f of x plus 1. Now, if x is greater than 1, if x is greater than 1, then f of x plus 1 is 0. So f of x plus 1 would be 0 in this case. So the integral would be I is equal to 1 to root 2 x dx by 2. So this is 1 by 2, 1 to root 2 x dx. This is 1 by 4 x squared, 1 to root 2, and this is 1 by 4 into 1. So this is 1 by 4. So I is equal to 1 by 4. So we have to find 4i minus 1. 4i minus 1 is equal to 4 into 1 by 4 minus 1, 0. So 0 is the correct answer to this question. Thank you.